So the remainder theorem says we have a polynomial f of x, and we divide it by something, so we divide it by x minus a. The remainder is a constant, which is called f of a. And this is just the notation saying that when we divide something, we have the quotient times what we were divided by plus the remainder. That's the same thing like if we take 21 divided by 5. Right, 21 divided by 5 would be 4 with 1 left over. So it's saying we would take 4 times 5 and add 1 to it. It's just saying it in terms of polynomials. You don't really need to worry about what this formula is. We just need to know about what the remainder is. So what we're really concerned with here is that here we divide it by x minus a, and that our remainder, our constant, is f of a. Okay, now this would be important because if we can figure out what the remainder is, we then know whether or not that polynomial fit into it evenly, and we would also be able to figure out what f of a would be without having to actually plug it in to the equation. And then the factor theorem says that x minus a is a factor if f of a is 0. So if there is not a remainder, when you divide things out, it's a factor. So like 20 divided by 5 is 4. There is no remainder, so 4 is a factor of 5. We're just dealing with polynomials now instead of just numbers. So we're going to have to remember how we use synthetic division. We're going to be using synthetic substitution, which is the same process as synthetic division, to help us decide if we have factors and also to help us find remainders. You guys remember synthetic division?
I don't know what I'm doing yet.
You remember doing it? Okay. So we're gonna start off by trying synthetic substitution to figure out what f of a is. So for the first one, we're going to find f of 6. For the function f of x is equal to 2x to the 4th minus 5x squared plus 8x minus 7. So one way how we could have found f of 6 beforehand is just taking the 6 and plugging it in for all of our x's. And that certainly works. But we're going to try doing it with synthetic substitution. So we set it up the same way we do synthetic division. So for synthetic division, we only cared about the coefficients. And so here our first coefficient is 2 on the x to the 4th. And then there's no x to the 3rd, so we would have to put a 0 placeholder in. The next coefficient is negative 5, and then 8, and then negative 7. And then over here, we're going to find f of 6. So in our box over here, we're going to put 6. Draw the line down, and we're going to search for that remainder. Starting to refresh you? Yeah? So what do we do first for this? Yeah, drop down the 2. Drop down your first value. And then you start with multiplying. So 2 times 6 is 12. Now we add our next column together. So 0 plus 12 is 12. Okay. Then we multiply again. 12 times 6, 72. Negative 5 plus 72. 67. 67 times 6. 402. 402 plus 8. 410. 410 times 6. 2,460, and then negative 7 plus 2,460. Yep, 2,453. So that's our remainder. So that tells us that f of 6 is equal to 2,453. That also tells us that 6 is not a factor. is not going to be one of the solutions for this graph, or for this equation.
How do you know that?
So we didn't get a 0 for a remainder. If we had gotten a 0 for our remainder, then that was one of our solutions that would have worked. Is that okay? So it's just synthetic division, and you're looking for the remainder.
I understand it now more than I did the last time.
All right, so now we're going to do the same type of thing, and we want to show that we have a factor. Okay? So I'm actually giving you the factor that works. So we want to show that's a factor. So we want to do the synthetic division and get a 0 for the remainder. And then we're going to see if we can find any remaining factors. So we're going to see if we can factor what we have left. So use synthetic division to show that x minus 4 is a factor of f of x is equal to x to the 4th plus x cubed minus 17x squared minus 20x plus 32. So to show it's a factor, we need a 0 in the remainder. So these all will be factors when I say show it's a factor. So if you don't get a 0, you made some sort of error somewhere. So we're going to set up synthetic division here. So what would be my numbers lined up at the top for synthetic division?
1, -17, -20, 32.
Yep. And now over here in the box,
I don't know what goes in there.
well, that's it. We want to show that x minus 4 is a factor. Well, if x minus 4 is a factor, what number would actually be the solution?
Or plus
Positive 4, because x minus 4 would have to be 0 here for it to be a solution. So we'd want to put a positive 4 over here. And then we do the same process. So drop down our 1. 1 times 4? 4. And we add 1 plus 4. 5. Multiply 5 times 4. 20. We add negative 17 plus 20. 3. Multiply 3 times 4. 12. Negative 20 plus 12. Negative 8. Negative 4 times, or negative 8 times 4. Negative 32. We add to get 0. So that right there is showing that it's a factor. Because we got a 0 here, we showed that 4 is indeed a solution to this equation. Okay? What is our remaining polynomial that we have left? What exponent would this one start off with? X to the 3rd. So this is saying our remaining polynomial is x to the 3rd plus 5x squared plus 3x minus 8. This is our remaining polynomial, our quotient that was left. Because we found one of the factors that were in there. We started off to the 4th power. Since we found one of the factors, our highest power is now the 3rd. Yep. Your answer is this whole thing. Showing it and writing down the remaining polynomial. This is the whole answer. Well, right. So I'm looking for your entire work for this. Is showing it all. So. Okay.
I don't remember how to find what the remainder polynomial is.
You just look at your coefficients that you have here. Notice we have 1, 5, 3, negative 8.
Okay, and then you just put it. Okay, I remember that now.
Okay. We do want to see if we could factor our resulting polynomial to see if we have any other solutions. Does anyone see if we could factor this easily? Our highest exponent, is it a square? No, so it's not a quadratic. It's a cube. There's 4 terms. So maybe you'd think about grouping, but do those have really anything in common? Not really. So we as of today, we can't find any more solutions. Next week we'll be able to, but as of today we can't. So that would be it for this problem. Is that okay? Let's do another one. So we want to show that x plus 3 is a factor of x cubed plus 6x minus 30. And then we want to find the remaining factors. So we're going to want to set up for our synthetic, so what values will go? Yep, 1, 6, -1, and -30. Okay. Now we want to show that x plus 3 is a factor of this. So -3, right? So -3 would be one of the solutions. So we'd put -3 over there. So drop the 1 down. 1 times -3, yep, is -3. 6 plus -3, 3. 3 times -3, yep, -9. -1 plus -9 is good. -10. -10 times -3, positive 30. We add to get 0. So there we showed that it was a factor. Okay, so that shows that it works. So now let's write down the polynomial we have left. Yep, x squared plus 3x minus 10. Okay, so can we factor this? Yeah? Okay, how would x squared plus 3x minus 10 factor? Good, x plus 5x minus 2. So what would be our other factors besides just x plus 3? Yep. Well, these are actually our factors. We could keep it like this. Our solutions here would be the -3, which we found. What would be the solution from x plus 5? -5. And the solution from x minus 2 is positive 2.
Do they always look the same?
Well, if we want x plus 5 to equal 0,
Okay, yeah.
we'd have to subtract the 5 over, so that's why the sign is opposite. Yeah, so these are our remaining factors. These are the resulting factors, and these would be the solutions. Yeah, Joshua? Oh, how do you know that it is? It's saying that we have this polynomial. This is lacking the f of x here. I neglected to type that in, so that's why. Yeah, the f of x should have been there. Otherwise, is this okay? All right.